Intertidal regions are places where marine ecosystems meet terrestrial ecosystems as the environment changes throughout the day. We'd like to introduce the life strategies of invertebrates in intertidal regions. According to different vegetation, we can distinguish 3 different regions in intertidal zones. The area floods during high tide and then drains during low tide. The organisms have adapted to cope with these dynamic conditions. The first region is the tidal flat, which is bare with no vegetation. It depends on marine resources such as marine detritus, phytobenthos, and marine macroalgae. The second region is the transition zone, where vegetation is present. The third region is salt marsh, which contains complex vegetation cover with more species such as Spartina anglica. The change in sediment is very important. In a tidal flat, there is mostly sand and mixed sediment near the sea, and the salt marsh is mostly covered in mud. Salt marsh sediment also contains higher amounts of total organic carbon because of the decaying vegetation. The amount of marine resources decline with increasing distance from the sea. The study focused on benthic invertebrates inhabiting the marine terrestrial transition zone at the island of Spekerroog in the Wadden Sea. Despite the significant changes and diverse habitats throughout the intertidal zone, invertebrate communities were similar in all the zones except the upper salt marsh. The upper salt marsh is the most remote area from the sea, as it is rare that it gets flooded unless there is spring tide present or a storm. Invertebrate species can tolerate different salinity and have adaptations against desiccation. This allows them to survive in a wide range of habitats. The most abundant invertebrates in the whole transect were surface deposit feeders, especially the snail Peringia ulvae, followed by subsurface deposit feeders, mostly Oligochaetes enchytridae. However, only a few species were able to inhabit the whole gradient. To exploit diverse niches effectively, those species needed to change their feeding modes. Some of them use different food resources, but others can even change their feeding strategy and thus their trophic position. The deposit-feeding snail Peringia ulvae dominated all the habitats, even though it didn't change its feeding mode throughout the transect and its trophic position remained the same. It used different food resources in different zones. However, omnivorous polychaete Hedis diversicolor underwent habitat-related trophic shift in the diet. It changed its feeding strategy and trophic position. In non-vegetated areas, that is, in tidal flats and lower transition zone, Hedis feeded on marine detritus, microphytobenthos, and benthic macroalgae. In higher zones, the presence of vegetation clearly prevents polychaete from feeding on marine resources. Instead of that, Hedis turns into a predator and its main food resource is the oligochaetes. In conclusion, this study sums up how different species adapt their feeding habits based on dynamic intertidal zones. Thanks for watching.